We're going to talk about section 7.8 in our book, inverse trig functions. Inverse functions in general are kind of tricky, and when you throw in the trig complication, I think it becomes even more so. So we'll try to sort this out. So first we just ask a question in general. What is the angle theta? And we're looking for all the possible angles between 0 and 360 in degrees and between 0 and 2 pi in radians, for which cosine of theta is equal to square root of 3 over 2. So remember, cosine is positive in quadrants 1 and in 4, quadrant 1 and 4. This is a known value, so if you remember, cosine starts big, so it's going to go 1 square root of 3 over 2. So in quadrant 1, we could say that an angle for which cosine is equal to square root of 3 over 2 would be 30 degrees, or pi over 6 in radians. Now, it would also be there would also be an angle here in quadrant 4 with that same reference angle, where cosine would also be a positive square root of 3 over 2. So that angle would, since the reference angle is 30 degrees, it'd be 360 minus 30 is going to be 330 degrees, or 2 pi, which is 12/6 pi, minus 1/6 pi would be 11 pi over 6. So those are a couple of positive angles as we go in the positive direction around the circle. And I guess that's all we're interested in here, because we can go from 0 to that. So what you see is, and it's not the radians and degrees here that's the issue, and I'm going to maybe direct our attention more to radians, because this is kind of where we're heading anyway in our course of study. The problem here is that there's going to be two of those answers. So when we want to know what's the angle whose cosine is square root of 3 over 2, if we're only going between 0 and 2 pi, we can come up with two different angles. If we didn't have the restriction from 0 to 2 pi, there would be an infinite number of angles, because we could keep going around the circle as many times as we want and end up at one of those places. So there are lots of angles whose cosine is square root of 3 over 2. So if we're thinking of our function as the cosine of x or cosine of theta, then what we've really been talking about here, asking the question, is what is the f inverse of that function? What's the inverse of that? So remember, a cosine function, you input an angle and you output some number between -1 and 1. And we were asking the other direction. If we are going to input a square root of 3 over 2, what are the possible outputs going to be? What angles would give us that cosine to equal square root of 3 over 2? And we can see there's multiple, and that's a problem, because if we want our inverse to be a function, that is, if we want it to be an inverse function, then functions have this property that each input has to give exactly one output. And so our issue then is that our starting place, our function y equals cosine of x, is not a one-to-one function. And we can see that graphically pretty clearly. You know, if we see our sine curve and it goes on and on and on forever, sometimes called a sine wave, it is clearly not going to pass the horizontal line test to be a one-to-one function, because a horizontal line is going to intersect that curve in an infinite number of places. So the way around that, what we do then, is we start with our cosine x function and we restrict its domain. So we choose a domain to be only between 0 and pi. So if we're only going between 0 and pi, we're only going to get this part of our cosine function. And so on that restricted domain, we can see that the cosine function is one-to-one. It will pass the horizontal line test. We'll see that its range, we're going to get all the things that cosine can do, because the smallest value we can get out of a cosine is -1, and the largest is positive 1, and we're going to get that on our domain from 0 to pi. So on that restricted domain, we do have an inverse function, and that's what we call the inverse cosine. Now, this might be a little bit unfortunate notation. This -1 we see right here is read as the inverse cosine of x. It is not cosine of x to the -1 power. Remember, cosine of x to the -1 power would be the reciprocal of cosine, which we already have a name for. We call that the secant. So the -1 there is not intended to be an exponent. It's to give this idea of an inverse function. So if we restrict the domain of our cosine to be 0 to pi, and when we switch the x and y's, that's what we get for inverses, that means our range for the inverse cosine is going to be from 0 to pi. And if our range on the cosine function goes from -1 to 1, that's going to be our domain for the inverse cosine. So we can input any value between -1 and 1, and what we will output is going to be an angle in radians, or we can do degrees. We'll mostly talk about radians, but degrees would be okay too. But we're going to output an angle. And for an inverse cosine, we're only going to get angles between 0 and pi. Okay, so let's see if we can sort this out a little bit. Now, if we want to know what is the angle whose cosine is square root of 3 over 2, then we know there are lots of angles whose cosine is square root of 3 over 2, but there is only one correct answer to an inverse cosine, because an input can have only one output if this is to be a function. And remember, what we're going to get out of a cosine inverse, our outputs have to be an angle between 0 and pi. So if we think in terms of like unit circle, we're talking about just this part of our unit circle that's in quadrant 1 and quadrant 2. Cosine is positive in quadrant 1, so we want the angle in quadrant 1 whose cosine is square root of 3 over 2, and that's going to be pi over 6. That is the only correct answer. It's true that cosine of 11 pi over 6 is also equal to square root of 3 over 2, but that is not a correct answer to the inverse cosine of square root of 3 over 2. Now, if we want an inverse cosine of a negative square root of 3 over 2, the negative quadrant for an inverse cosine is going to be in quadrant 2. So we have the same reference angle that we had before. That's going to be a reference angle of pi over 6. Now, it's true that you could get to this angle using 5 pi over 6. You could also get there doing a negative 7 pi over 6, but there is only one correct answer. And remember, an output to an inverse cosine has to be between 0 and pi, so the only correct answer to an inverse cosine of negative square root of 3 over 2 will be 5 pi over 6. Now, a further complication, we have multiple notations. So sometimes we will see an inverse cosine written using this functional notation, implying that is an inverse function. Sometimes you will see it written as an arc cosine, maybe suggesting more of an angle in radians, that arc length that gives you that angle, which is what we get for an angle in radians. These are synonyms. They are interchangeable. They mean the same thing, so you just have to recognize them and not get confused, because we'll switch back and forth between those for maybe no apparent reason. Okay, see how we're doing here. Can we figure out what the inverse cosine of negative 1 is? Remember, in a cosine function, you input an angle and you output a number between negative 1 and 1. an inverse cosine. We're going to input a number between -1 and 1, and we're looking to output an angle. We want the angle whose cosine is -1, and we want that angle to be between 0 and pi. Since the cosine of pi is -1, that means that the arc cosine of -1 is pi. That is the one and only correct answer. And arc cosine of -1/2, that's the angle whose cosine is -1/2. And cosine, and it has to be a quadrant 2 angle since this is a negative value. Cosine in quadrant 1 is 1/2 with a reference angle of pi over 3. And since we're in quadrant 2, to make that cosine be negative, the only correct answer is going to be 2 pi over 3. Now, the arc cosine of 0.2 is not one that we know from memory, so we need to go to our calculator for this and make sure your calculator is in radian mode, and you'll go second cosine 0.2, and when I do that I'm getting 1.369. So we would say that's 1.369, and that's in radians. Okay. Let's see if we can understand the difference in these notations, because it can be confusing when we're starting. So when we see it written this way, we read that as an inverse cosine of x. That is not the cosine of x raised to the -1 power, which would be a secant. Now here, that's what you see. This is what we mean by the reciprocal of cosine. This is 1 over cosine of x, or we could also call that a secant of x, because those are the same thing. This is not. We could call this alternatively an arc cosine of x. Those mean the same thing. Now what we mean by the middle thing here is we're going to take the cosine of the reciprocal of that angle. That's the cosine of 1 over x. Okay, I know that gets a little confusing. Let's see what that looks like if we actually plug in a particular value for x. So what that means now is we're looking for here an inverse cosine of 1/2. Now we don't need a calculator for this one. We're asking for what is the angle whose cosine is 1/2. And it's got to be either a quadrant 1 or a quadrant 2 angle, because it's got to be between 0 and pi. Since 1/2 is positive, that narrows it down to quadrant 1. And cosine of pi over 3 is 1/2. That makes the inverse cosine of 1/2 pi over 3. It's the angle whose cosine is 1/2. Now what we want on the next one is we're asking for the cosine of the reciprocal of 1/2. That's the cosine of 2. And I don't know that one, so I'm going to go to my calculator, and cosine of 2 radians is a -0.416. It's going to be a -0.416. Now what we're getting for the next one is it's going to be 1 over the cosine of 1/2. Now cosine of 1/2 is not something we know, so I'm going to go to my calculator and go 1 divided by the cosine of 1/2, and I'm getting 1.139. Hope that helps clarify a little bit. Okay, now's where it gets where you have to think really hard. When we take the cosine of the inverse cosine of square root of 2 over 2, you can reasonably think of that as being like f of f inverse of x. And these are going to undo each other, and we're just going to get the x. And in this case, that's true. And we can just think of those as canceling, and we're going to get square root of 2 over 2. If you wanted to do it the long way, you could say the angle whose cosine is square root of 2 over 2 would be pi over 4. And the cosine of pi over 4 or right back to square root of 2 over 2. Now here's where you got to be careful. We're saying this looks, at first glance, which it is, as f inverse of f of x, which we think would be x, and we might say, well, that's got to be 7 pi over 4, but that would be wrong. Because remember, we have restricted our domain and range, so what we get out of a cosine inverse has to be an angle between 0 and pi. So what we're seeing, I'm going to give you a visual here. 7 pi over 4 is like 1 3/4 pi. There's 1 pi, 1/4, 2/4, 3/4. It's going to be all the way over here. Now, the cosine of 7 pi over 4, that reference angle is pi over 4. Because we're in quadrant 4, the cosine there is positive. So what we're saying is, what is an angle that's equivalent to 7 pi over 4, the cosine of that angle will be the same as the cosine of 7 pi over 4, but that angle has to be in the range of inverse cosine. It has to be an angle between 0 and pi, and that would be pi over 4. This is going to be tricky. All right, let's see if we can figure this out. Sometimes true or always true is the cosine of the arc cosine of x always equal to x or sometimes equal to x. And in this case, like we saw in this one up here, this will always be true. Okay, so this cosine will undo that inverse cosine. Now, this one we have to be careful because remember, the range of an inverse cosine is only 0 to pi. So our answer to an inverse cosine has to be an angle between 0 and pi. Now, the angle that we plug in here has no restriction, like we saw up here. We could put in any angle we want. What we are looking for is the equivalent angle between 0 and pi, whose cosine will still give us whatever the cosine of that angle is. So this is only sometimes true. If our angle is outside of 0 to pi, then we are not going to get that same value x. We're going to get an equivalent angle whose cosine is still the same as the cosine of that particular angle. Whew, complicated stuff. All right. Now let's go on beyond inverse cosine we want to talk about inverse sine and inverse tangent. Now next year we'll also talk about inverse cotangent, inverse cosecant, and inverse secant. But in AP Prep this year, we're just going to worry about inverse cosine, inverse sine, and inverse tangent. Now we have the same issue that we did before in that a sine curve is not one-to-one. So we want to restrict our domain again. Remember, with an inverse cosine, we restricted our domain from 0 to pi. But that isn't going to work for an inverse sine because it won't be a one-to-one function if we go 0 to pi. But it will be a one-to-one function and do everything that we want it to do, everything that a sine can do, and include quadrant 1 if we make our domain be negative pi over 2 to positive pi over 2. The range, we will get y values going from negative 1 to 1. So if we restrict our domain on the sine curve to negative pi over 2 to pi over 2, we'll get a range of negative 1 to 1. That will make for our inverse sine, or arc sine, it's also known as, its domain will be negative 1 to 1, and its range will be negative pi over 2 to pi over 2. So we'll get answers to an inverse sine that are going to be between negative pi over 2 and pi over 2. Similarly, for an inverse tangent, we can see that the tangent's going to do everything that it's going to do in between negative pi over 2 and pi over 2. Now, technically, it's not defined at negative pi over 2, so I'm going to use the notation that indicates we're not including that endpoint. Our range, because a sine goes forever up, or a tangent rather goes forever up and forever down, its range will be all real numbers. So for an inverse tangent or arctangent, its domain will be all real numbers, and its range will only get angles between negative pi over 2 and pi over 2. So sine and tangent are very similar, and cosine is kind of the outlier. Okay, see if we can make sense of this. Okay, so we want, remember now, we're inputting a number between negative 1 and 1, and we are trying to output an angle. We want the angle whose sine is negative 1/2. That's what this means. Now, if we ignore the negative sign for a moment, the angle that makes sine equal to positive 1/2 is going to be pi over 6. Now, an inverse sine has a range between negative pi over 2 and positive pi over 2. So if we want a quadrant where sine is going to be negative, it's going to come from quadrant 4. And so we're going to call that then a negative pi over 6. That is the one and only correct answer. You cannot call it 11 pi over 6 because that is outside the range of an inverse sine. An arc sine, remember, means the same thing as an inverse sine. The angle whose sine is square root of 3 over 2 is going to be pi over 3. And our positive quadrant for all of our inverse functions is quadrant 1. And so for an arc sine as well, this will be pi over 3. That's the only correct answer to an arc sine of square root of 3 over 2. Now, looking at the inverse tangents, these are always hard. So I'm going to suggest, I'll show you a couple ways. The kind of standard way that's going to work no matter what is I'm going to draw a reference triangle in quadrant 1, and I'm going to call this the opposite and the adjacent. And then we can find the hypotenuse. So I'm going to turn our inverse tangent into an inverse sine or an inverse cosine. So using a little Pythagorean theorem, c squared is going to be the square root of 3 squared plus 3 squared. That's going to be 12. C is going to be the square root of 12, which we know is 4 times 3, so that's 2 square root of 3. So I'm going to call that hypotenuse 2 square root of 3. And I like sine, so I'm going to say the sine of that angle is opposite square root of 3 over hypotenuse 2 square root of 3. We can cancel the square root of 3's. It's 1/2. So now I have turned this inverse tangent, which is tough. What's the angle whose tangent is square root of 3 over 3? I've turned that into an inverse sine. What's the angle whose sine is 1/2? I'm more comfortable with that. The angle whose sine is 1/2 is going to be pi over 6. And so that's going to be our inverse tangent. Now, if you get really good at this, and I'm not saying you have to do it this way, but when you've done a couple thousand of these like I have, I can see square root of 3 over 3. I can unrationalize it, and I can recognize 3 as being the square root of 3 squared. And so really this is, what is the angle whose tangent is 1 over square root of 3? And so I can think of that as being sine over cosine equal to 1 over square root of 3, and then see that 1 over square root of 3 as a 1/2 over square root of 3 over 2, and say, well, the same angle that makes sine 1/2 makes cosine theta square root of 3 over 2, and makes tangent of theta square root of 3 over 3, and I can get to the pi over 6 that way, but this method is also perfectly okay. Now, inverse tangent of -1, first let's ignore the negative sign. We want to know the tangent of what angle is going to equal a -1. That's what this means. We're looking for the angle whose tangent is -1. Now, if I ignore the negative sign, Tangent will be 1 when sine and cosine are the same. And sine and cosine are the same at pi over 4. Now, to be negative, remember our, our, um, our range for an inverse tangent is like that of an inverse sine, and so its negative quadrant is going to be quadrant 4. So if our reference angle is pi over 4, and our angle resides in quadrant 4, then that must be a negative pi over 4. And that's the only correct answer to an inverse tangent or arctangent of negative 1. Whew. Now, you're going to see some problems in your homework in our book that will say, give expressions for the angle and the value of the trig function. And then they're going to give you some expression here, like you see in the green. So they're trying to make sure you understand that in this expression, sine of k equals a, one of these is an angle, and one of them is the value of the trig function. And can you sort that out? And so an input to a trig function is the angle. So that means the angle is going to be k. And the output, that is the sine of that angle, is that a. So our trig value is the a. That is, that's the value of the sine of that angle. Now, it's a little trickier with the inverse. So now remember, we're on an inverse, we're switching input-output. So in our sine function, we inputted an angle and we outputted a number between negative 1 and 1. So this is going to be, the input is going to be a number, and the output is going to be our angle. So this is equivalent to saying the tangent of angle n is 1 over x. And this is what they're trying to get you to understand in these kind of questions in the book. The angle is going to be n. That's the answer to an inverse trig function. Inverse tangent, inverse sine, inverse cosine is equal to an angle. It's the angle that gives you the tangent of that, and that's the value of our trig function. In this case, it's the value of that tangent. Okay, good luck.